Okay, we'll do some sample problems for 3.3, and we'll start with number 7. It starts out looking like this. Okay. So, the first thing, the easiest thing, the first thing we should do that makes it the easiest, I should say, I think, is to write these both so that they look like they're in slope-intercept form. So we just need to get y on one side by itself. We can add x on both sides for this one. It'll be y is less than x minus 3. Okay, this one will add x to both sides as well. This will be y is greater than x plus 4. And now we graph them both. Maybe we should use a little, this can get pretty confusing. So we'll use green for that one. We'll use red for this one. Okay. So we'll graph the green one first. We've got our slope-intercept form. Y-intercept is at -3. So there, and our slope is a positive 1, so up 1 and to the right 1. And it's less than, so it needs to be a dotted line. It's not less than or equal to, it's just less than. Okay, and we need to shade below, because y is less than. We need y values that are less than the y values on the line. And so those values would be below. All right, on to the red one. We've got a y-intercept of 4. And a slope of positive 1. And it is it needs to be a dotted line. So we're up 1 to the right 1. And we need a dotted line. Let me just erase that other stuff. Okay. And where do we shade? We need to shade greater than this line, so above this line. Okay, and so what are we looking for? We're looking for the solution. We're looking for solutions that work for both of these. Okay, and reminding ourselves what a solution for an inequality is. For this one, it's nothing on this line, because anything that you pick on this line for the red one would make both sides equal, and equal is not an option. Okay, so not on the line, but anything above the line will make this side greater than this side, and that's what we're looking for. So the shaded region is the solution for the red one. The green shaded region is the solution for the green one. So if we want a solution for both of them, we would need to see where the shaded region of the red one is in the same place as the shaded region for the green one. So will that ever happen? Will these shaded regions ever overlap? Well, these both have the same slope, so it means they're parallel, which means they'll never intersect, ever. That's the definition of parallel. And so we have no solutions. These lines are parallel, they're shaded in opposite directions, so there's no way that their shaded regions are going to overlap. So this would be no solution. There is nowhere that these two shaded regions will overlap, and so there's no way that we could find a solution for both of them. Okay. Number 12. No. X plus y is greater than or equal to -3, and -6x plus 4y is less than 14. Okay. We'll we'll do this one in blue and this other one in gold. Okay. Well, first it would be helpful if we rewrote them in slope-intercept form. So we're going to subtract x on both sides, and we'll get y is less than or equal to negative x minus 3. For this other one, we'll have a couple of steps here. We're going to add 6x to both sides. We get 4y is less than 6x plus 14. And divide by 4. So y is less than 3 halves x plus 7 halves. Kind of a weird thing. Just make sure that that's written out correctly. Okay. So let's do the blue graphing. Y-intercept of negative 3. Slope of negative 1. So up 1 and to the left 1. And it's less than or equal to, so it is a solid line. Okay, so there's our line for the blue inequality, and now for the gold one. Y is less than 3 halves x plus 7 halves, so 7 halves is our y-intercept. So you got 2, 4, 6, 8, so 7 halves there. And 3 halves is our slope, so I'm going to go down 3 and to the left 2, down 1, 2, 3, and to the left 2. Let's say that's 1 and that's 2. Alright, and this needs to be a dotted line because it is strictly less than, not less than or equal to. Okay, and of course, I've forgotten the shading part, so let's go back to the blue one and shade that. Where are we going to shade? We've got the equals to part, that's the solid line. The greater than part is that y needs to be greater than this, and this is, we could think of this part as the line. So y needs to be greater than the line, and greater than in the vertical, and that's y is vertical, that's above. So anything above this line. And for the gold, anything less than this line, below this line. So we need to shade below the gold line. Okay. So where's the solution? It's the solution for both. If we said this was a solution, that couldn't be, because this is a solution only for the blue. It's not in the solution area for the gold. And likewise, this is only for gold, not for blue. This is for gold and blue. And so this guy right here, where they overlap, is the solution. Okay. In our next one, let's do the shading in a way that is a little less messy. All we're going to show is the solution area. Okay. That'll be number 14. (3x minus y) is greater than 12. Negative x plus 8y is greater than negative 4. Alright, and so we'll pick some colors here. We'll do purple and gray. Okay, so purple, again, for each of these, we're going to put them in y-intercept form, slope-intercept form. So we'll subtract 3x on both sides. We have negative y is greater than negative 3x plus 12. And then we need to have a positive y, so we'll divide both sides by a negative 1. So y, and this negative 3 will become a positive 3, and this positive 12 will become a negative 12. And remember, when we multiply or divide both sides of an inequality by a negative, we need to change the direction of that sign there. Okay. And now for the gray, we'll start over here. We'll add x to both sides, giving us 8y is greater than x minus 4. And then we'll divide by 8 on both sides. Y is greater than 1/8 x minus 1/2. All right. Alright, so for the purple first, y is less than 3x minus 12. Our y-intercept is at negative 12, so we'll go 6, 12, and up 3 and to the right 1. So this would be 3 and to the right 1. Right, and it's strictly less than, so dotted line. And the gray one. Y-intercept of negative 1/2. Okay, so this would be 3, this would be 1, so 1/2 would be right in there. And the slope is 1/8, so up 1, which would put us at positive 1/2, and over 8, so this one we made 1. So this would be 2, 3, 4. Okay, so our other point for this one would be right there, and it's strictly greater than. So dotted line, that's what that means. Okay, remember I said we're going to do this in such a way that's a little neater. The shaded region is just going to be the solution. We're not going to shade it and then, you know, reshade the overlapped area. So for the shading part of the purple one, we would shade below, because less than would tell us that the y needs to be less than this line here, so below the line. So I'm just going to give myself a little bit of an indication, so just a tiny bit of shading to remind myself which way I would go. I would shade below here. And for the gray, this needs to be greater than, y needs to be greater than the y values on this line. So above, and I don't even need to bother with doing all of that, because I can see it's going to be above here, and below here, this will be the intersection. So we could just grab a red one and say, here is where the intersection will be between these two. Because I know I would shade below the purple and above the gray, and that's where they would intersect, and nowhere else. Okay. So now let's go on to a problem that has 3 things to graph. That'll be number 20, just 20. Alright, I saved you from having to watch me write all those down. I've already picked some colors, so now we're going to continue on from here. We need to get y by itself. I guess we don't need to, but I think it's the easiest way to do it. So y would be less than x plus 5. We'll get the red one going here. We got negative y is greater than negative 2x plus 0. We don't need to write plus 0. Then we need to divide both sides by a negative 1. So y is less than, now we need to flip that inequality around, less than positive 2x. And the green, we get 5y is greater than x minus 20, or y is greater than 1/5 x minus 4, divide both sides by 5. Make sure that looks right. So we'll start with the black one again. We got a y-intercept of 5. And a slope of negative 1, so down 1 into the right 1. And it needs to be a dotted line because it's strictly less than. And we'll give ourselves a little shade indication. Which way would we shade? We would shade less than this line, and for y, less than would mean below. So we would just give ourselves a little indication we would shade below this line. Go on to the red one. We have y equals 2x. Like we said, we could put plus 0. That means the y-intercept is 0. And the slope is 2, so up 2 and to the right 1. And it is strictly less than, not less than or equal to, so we will put a dotted line. And where are we going to shade? We would shade less than this line, so below this line, so we could even do like We could just put an arrow here if we wanted to. Just a little side note for ourselves, so that when it comes time to find the intersection of all these, we know where the shading would be for this red one. When you get 3 or 4 things to graph, it's a lot less messy if you do it this way. Though I won't count you incorrect if you do it some other way. That would be silly. So our y-intercept is -4, and our slope is 1/5, so up 1 and over 5. So let's mark off 5. Up 1 and to the right 5. It is a dotted line as well. And it needs to be greater than, so we would shade above this green line. And let's shade the intersection with this light blue color. And so now we're looking for the intersection of all 3 of these, the overlap of the solution areas of all 3 of these inequalities. So we'd shade below this this black line and below this red line. So we're looking like in here, in this wedge would be the solution for those 2. And now we involve the third one. The third one would be above here. So trapped between all 3 of them turns out to be this triangle shape. Okay. Now I've had in the past people get confused when they have 3 things to shade and they think it always has to be a triangle. That's not true. If instead of, for the green one, for instance, instead of above, if we shaded below, then the intersection would be down here. So don't get trapped thinking that it has to be a triangle when you graph 3 things. It doesn't have to be. But there it is for this one. It does happen for number 20. Right. And let's go on to number 34. Alright, so this summer you're going to work as a dog walker and as a car washer. Or I guess maybe the summer you did, seeing as it's probably after summer as you're watching this. So let's use D. There's obviously going to be some variables involved. We're wise to that. D for dog walking, C for car washing. Let's see if we can pull some information out here now. You can work at most 20 hours next week. Okay, so in a week, you can work at most 20 hours. So my guess, with my experience, would be that our variables are going to stand for some amount of hours, since they've started in about hours. You need to earn at least $92 to cover your weekly expenses. Your dog walking job pays $7.50 an hour, so dog walking is $7.50 per hour. And car washing is $6 an hour. Okay. And we want to write a system of linear inequalities to model the situation. Okay, we just want to write it. Doesn't necessarily say to solve it. So what 2 inequalities can we write with the information that we've been given? And especially you should pay attention to at least and at most, that kind of thing. So you can work at most 20 hours. I would say that D and C stand for the number of hours you're going to work at each of these jobs. So at most 20 hours. So let's say 20 hours. Okay. And this stuff over here that we're going to write is going to have variables in it. Needs to express that 20 is the most that you could work. Okay. So whatever we write over here, this expression that we write, which I think is pretty clear, that the hours that we work dog walking plus the hours that we work at the car wash are the hours that we work in total. So we're going to say that the number of hours that we work in total needs to be less than or all the way up to being equal to 20 hours. That's the most that we could work at most. Okay. And then we have a certain amount of money that we need to make to cover our weekly expenses. That's $92. Okay. and we need to make at least $92. So 92 is going to be the least. It's going to be less than or equal to the amount that we make at our jobs. All right? This is the amount that we need to make to pay our bills, and this is the amount that we make actually working. So clearly we're going to take the amount that we make at dog walking, right? The amount of money dog walking, plus the amount of money we make car washing, and that'll be the amount that we make at our jobs. How do you decide how much you make at dog walking? If you've ever had a job, I think you know pretty quickly how to take the rate at which you're paid and find out how much you get paid overall. You take $7.50 an hour times however many hours you worked. You take $6 an hour times however many hours you worked. So 7.5D plus 6C. Okay. And we could clean this up a little bit. Just like that. 7.5D plus 6C. So we have this system of equations. We could say D plus C is less than or equal to 20, and 7.5D plus 6C is greater than or equal to 92 if we read it right to left. Okay, and that's all it asked for. Just asked to write a system of inequalities, not to solve it. And that's good enough. That'll do it. All right, thanks for watching.